Hello viewers, in today's video we are going to talk about multiple linear regression, that is via origin. So multiple linear regression is a statistical tool that is used to comprehend the linear relationship between a single continuous dependent variable and two or more independent variables. So we'll have a dependent variable and we'll have two or more or maybe three independent variables. So we are going to predict the dependent variable here, and it also models how these multiple independence factors simultaneously influence the outcome or influence the dependent variable, allowing for the assessment of each predictor's separate effect while controlling for others, ultimately providing a more accurate prediction than simple linear regression. Because in simple linear regression we have one independent and one dependent, and here we have one dependent and two or more or probably three independent variables. Now working on it, so we need to define a dependent variable and we need to define the independent variables, and then the multiple linear regressions assumes a linear relationship, meaning the relationship between the dependent and independent variables can be represented by a straight line in a multi-dimensional space. So we will have an equation, okay, and this where the dependent variable is a linear function of independent variables and a random error term. So this is the equation we are going to generate, and the y is the dependent variable and beta naught, the first term, is the intercept when all the independent variables are 0, and beta 1 to beta 2 is a regression coefficients indicating the change in y for a 1 unit change in the corresponding independent variable, and x1 x2 are the independent variables, and epsilon is the model's random error or residual. To perform a multiple linear regression in origin, you can use the built-in MLR regression dialog. So there we have to specify independent and dependent variables. Okay, now let us start the multiple linear regression, and to evaluate the model's fit we will have the residual plot. So this plot shows the residuals difference between the actual and predicted values, as we saw in the Excel and SPSS, against the predicted values on the x-axis. For a good fit, the residual should be randomly scattered around 0, not it should be deviating, so with no discernible pattern. A systematic pattern shows the model is not appropriate. And reduced chi-square, this value is close to 1 for a good fit. Now to assess the validity of the model, if the dependent variable should logically be 0 when all independent variables are 0, this model is appropriate. Okay, now we have a data here called the multiple linear regression. So here we have the first column, soil fertility, rainfall, pesticide usage, crop yield. Okay, so here basically we are going to predict the crop yield. So crop yield is my dependent variable and these are my independent variables. So you can see that we have already imported the data. In my previous videos I have shown you how to import the data. You can copy and paste, or you can even use this function to import the data. Okay, so now after importing the data, you can select, you can do the plotting, scatter, now what we need to do is, here as you can see here, this is the data from agriculture college or agriculture science, agriculture feed. So here the dependent variable is my crop yield, which is kg per hectare, and the independent variables are x1, x2, x3. The x1 is soil fertility index, and this is rainfall, and this is pesticide usage. Now already the data set has been generated, so instead of going to the plot, we'll go to the analysis, go to the fitting, and then we will use the multiple linear regression. Now as you can see here, the dependent data has already been selected, this one, and for example if it has not been selected, so you can select this way, and also for this one you can select these cells, okay, and let us do it again. So fitting, so if you are not selecting, for example analysis, and then here this one shows that you have to select one column and this one. So if we choose this one, and for this one you can choose this way, and then let us see the other options. So we'll keep it like this: quantities, also this one, residual analysis, regular, output, plots, and then we will say okay. And here we got the analysis done. So you can see the intercept, soil fertility, the rainfall, the pesticide usage, number of points is 30, degrees of freedom 26. This is, and we have very low R square, so this is not a good fit. And even the crop yield shows some weird values. And then these are my residual versus independent plots that you saw that we used to do in the SPSS. So you can see here it is scattered, bit scattered from the origin. Here similarly see the other plots, and also these plots. So this is all about the using of the origin um, for the multiple linear regression. You can try for other data also, and we have a couple of videos that talks about the use of multiple linear regression via origin, via SPSS, okay, and even you can do the same thing by Excel also, okay. So don't forget to like and subscribe my channel.